Let us now talk about right shift operator. Right shift is opposite of left shift. What happens in right shift is you shift all the bits right by the given positions. So I've shifted right this number x by 1. So what we do is we consider the binary representation of 33, which is our x. So binary representation is this, 32 plus 1, 33. When we right shift it by 1, what happens is all these bits are moved one position ahead, right? They move here. And this bit is ignored, right? And a 0 is added as a leading 0. So you get the output as last bit removed, these bits shifted, a 0 added. So what is the decimal value of this? 1, 2, 4, 8, 16. So your output is 16 for this program. Now let us guess the output of this program. We are now shifting 33 by 2. So what will happen? These bits, the first 30 bits, they'll move to the right side. These last two bits will be ignored and you will have two new zeros added at the beginning. So what is the decimal equivalent of this number? 1, 2, 4, 8. So the output of this program is 8. Let us do this example of negative numbers because this is really interesting. Because of negative numbers, we have one more type of right shift, which is called unsigned right shift. And this particular right shift is sometimes also called signed right shift because it treats negatives and positives differently. In case of positives, it was filling leading bits with 0. In case of negatives, it fills leading bits with 1 to keep the sign. So when you consider x equal to -2, first of all, let us see how did we get this binary representation of -2. How do we represent negative numbers in binary? In 2's complement form. And 2's complement representation of -2 will be 2 raised to the power 32 minus 2. And what is binary representation of this number? Please note that binary representation of 2 raised to the power 32 minus 1 means all ones. And if you do subtract 1 from it, you will get all ones except the last one, right? So this is the binary representation of this number -2, which is represented as this in 2's complement form. You will have 31 ones and then you will have a 0. Now if you right shift it by 1, what will happen? This bit will be ignored. These 31 bits will be moved to the right side. So you will have 31 bits, all ones. Now unlike positive numbers, in case of negative numbers, we fill the leading bits with 1. So we'll be filling a 1 here, not a 0. We'll be having a 1 here as the leading bit. So these 31 bits are shifted here. This one is ignored and we have a new one. Now what is the decimal equivalent of this number? If you find the decimal value of this number, you will see it's 2 raised to the power 32 minus 1. And since the leading bit is 1, it's a negative number. And what number represents? See, 2 raised to the power 32 minus x represents minus x, so it's -1. So output of this program is -1. Now a quick question for you. What will you get as an output if you shift it by 2? If you shift it by 2, these 2 bits will be ignored. These 31s will be moved to the right side. So you will be having 31s. And leading 2 bits, they'll be added as 1 because it's a negative number, right? So what is this value? It's again -1. So you will get the output again as -1. So if you shift -2 with any value greater than or equal to 1, you will always get -1. Let us now talk about unsigned right shift operator. This operator also shifts the bit to the right according to the number of positions given. If you are given 1, then it also shifts right by 1. If you are given 2, then it shifts right by 2. But the difference between previous right shift and this unsigned right shift is the previous right shift operation was filling the leading bits with 1 to ensure that sign remains same. Here in the unsigned right shift operator, we fill the leading bits with 0. Also, one more thing, this difference is only there for negative numbers. For positive numbers, they both fill with 0 and they work the same way. They get you the same result. But when you have negative numbers, then this previous right shift is filling ones and this right shift fills zeros. It basically considers negative also same as positives. So let's see what happens here. We have this x equal to minus 2, whose binary representation is this. When we right shift it by 1, we have this bit removed. These 31 bits move to the right side. And here in the unsigned right shift, we fill it with a 0. So the result that we get is a positive number because the leading bit is 0. Right? So when you apply unsigned right shift, your negative numbers become actually positive. So what is the value of this? The value of this is, see, there are 31 ones and then there is a 0. So what is the value of 31 ones? 2 raised to the power 31 minus 1. Right? That's the value that you will get and which has this value. So that's the output of this program. Now if you right shift it by 2, unsigned right shifted by 2, what you will get? You will have the binary representation of minus 2 as this. Then if you shift it by 2, these 2 bits will be ignored. These 30 bits will move here. These all 30 bits are actually ones. Then you will add 2 leading zeros. Since your leading bit is 0, it's a positive number now. And what is the value of this positive number? It's 2 raised to the power 30 minus 1. It has 30 ones. So that's the value of 30 ones. And decimal equivalent of this is this.